Hi, this is the Science Chef. In this video, we'll be learning about the different methods of preparing salts. Go nowhere, I will be right back after this time out. In our last tutorials on types of salts, we learned that salts can be classified based on their composition and solubility in water. Based on solubility, salts are grouped into soluble salts and insoluble salts. Soluble salts dissolve completely in water, while insoluble salts do not dissolve in water, or they do so sparingly. It is good we know some examples of soluble and insoluble salts, as the method employed in preparing a given salt mostly depends on the solubility in water and stability to heat. Examples of soluble salts include all nitrates, all chlorides except silver chloride, lead 2 chloride, mercury 2 chloride, etc. All sulfates except barium sulfate, lead 2 sulfate, while calcium sulfate is sparingly soluble. On the other hand, examples of insoluble salts are all carbonates except the carbonates of group 1 metals and ammonium carbonate. Similarly, all group 1 metals and ammonium salts are soluble. However, for the purpose of this lesson, our focus shall be on sodium and potassium salts. So having understood the criteria for choosing the appropriate method for preparing a given salt, let's look at the methods of preparing soluble salts. The methods used for preparing soluble salts in the laboratory are synonymous with the chemical properties of acids and include action of dilute acids on metals to form salts and liberate hydrogen gas. The soluble salts of moderately reactive metals like calcium, magnesium, zinc and iron can be prepared by the displacement reactions between the metals and dilute acids. For example, zinc chloride is produced when zinc granules react with dilute hydrochloric acid. The zinc metal displaces the hydrogen ion from the acid to form hydrogen gas as shown in the ionic equation. Similarly, magnesium reacts with sulfuric acid to form magnesium sulfate. In this reaction, the magnesium metal displaces hydrogen ion from the acid to form hydrogen gas and aqueous magnesium sulfate. Next is action of dilute acids on alkalis to form salts and water. Most sodium, potassium and ammonium salts are prepared by titration. This is because their hydroxides are alkalis, which means they are soluble in water. Titration is a method of determining the concentration of a solution, say an alkali, by slowly adding another solution of known concentration, say an acid from a burette to it in a conical flask, until the reaction is seen to be complete by the color change of an indicator. For example, sodium chloride can be prepared by the titration of dilute hydrochloric acid and aqueous sodium hydroxide. Similarly, ammonium sulfate can be prepared from the titration of dilute sulfuric acid against aqueous ammonia, also called ammonium hydroxide. Next is action of dilute acids on insoluble bases to form salts and water. On the action of dilute acids on insoluble bases, the dilute acid is heated and the insoluble base, most times oxides or insoluble hydroxides, is added a little at a time and stirred until no more base dissolves. The excess base is filtered off, leaving a solution of the salt as the filtrate. For example, zinc chloride can also be formed by dissolving zinc oxide or insoluble zinc hydroxide in heated dilute hydrochloric acid until it no longer dissolves and the excess hydroxide filtered off. Similarly, magnesium sulfate is also prepared by dissolving magnesium oxide in heated dilute sulfuric acid until it no longer dissolves and the excess base filtered off. Next is action of dilute acids on carbonates to form salts and water and liberate carbon dioxide. Just like the action of dilute acids on insoluble bases, insoluble carbonates can be added to heated dilute acids in little amounts and stirred until no further dissolution occurs. As the reaction occurs, bubbles of gases will be seen in the beaker, which indicates the liberation of carbon dioxide. The unreacted carbonate will be filtered off, leaving behind the desired salt solution as the filtrate. For example, zinc chloride can again be prepared by dissolving zinc carbonate in heated hydrochloric acid and filtering off the unreacted carbonate. Similarly, copper 2 sulfate can be prepared by adding copper 2 carbonate to dilute sulfuric acid until it no longer dissolves and the excess carbonate filtered off. Let's now learn how to prepare insoluble salts. Insoluble salts are prepared by a process called double decomposition or precipitation. Precipitation is a reaction in which two aqueous solutions react to form a precipitate and a supernatant solution through the exchange of radicals. A precipitate is an insoluble solid formed when two solutions are mixed together, while a supernatant solution is one that floats or lies above a sediment or precipitate. In the preparation of insoluble salts by precipitation, usually two soluble salts are used, with each of them containing the desired radicals of the insoluble salts to be prepared. While one contains the positive radical, the other will contain the negative radical. For example, in the preparation of silver chloride, aqueous solutions of silver nitrate and sodium chloride are reacted together. These salts react to form the silver chloride precipitate and a supernatant solution of sodium nitrate. Of the two reacting salts, the silver nitrate provides the silver radical, while the sodium chloride provides the chloride radical. Similarly, calcium carbonate can be prepared by reacting calcium chloride solution with potassium carbonate solution. While the calcium chloride provides the calcium radical, the potassium carbonate provides the carbonate radical. Potassium chloride is also formed as a supernatant byproduct. Another salt that can be prepared by double decomposition is barium sulfate by reacting aqueous barium nitrate and sodium sulfate solutions. The barium nitrate provides the barium radical, while the sodium nitrate provides the sulfate radical. Having learned the specific methods suitable for preparing soluble and insoluble salts, let's now look at a method that can be used to prepare both soluble and insoluble salts. Direct combination of constituent elements, as the term implies, is suitable for preparing binary salts. Binary salts are salts that contain only two elements. Examples are sodium chloride, iron 3 chloride, iron 2 sulfide, etc. While the first two are soluble, the last one is insoluble. The table on the screen shows a summary of some salts, the reagents, and the methods that can be used to prepare them. The preparation of a salt is not complete without its recovery from the reaction mixture. For insoluble salts, they can be recovered by simply filtering and rinsing them off from the reaction mixture and then drying the residue at a regulated temperature. However, the methods employed in recovering soluble salts from their solutions depend on their stability to heat. Soluble salts that decompose on heating are recovered from their solutions by crystallization, while those that are stable to heat are recovered from their solutions by evaporation to dryness. In our next tutorial, we'll be learning about the crystallization of salts in details, with examples of salts that can be recovered from their solutions by crystallization. So subscribe to our channel and don't forget to turn on the notification bell to get notified when the video is published. Always remain on top until I see you when I see you.